All right, so this lesson is going to build on what we learned about complex numbers. So we'll have lesson 2.4, day 2. And we're going to be finding complex quotients. And we're going to solve some equations using the quadratic formula that are going to have complex solutions. Okay, so one thing to keep in mind whenever we're doing complex quotients is that kind of like with square roots, it's not simplified if you leave a square root in the denominator. We also cannot leave an I in the denominator. All right, so what we're going to do, so our denominator has to be a real number. So if we want to convert an imaginary number to a real number, you can multiply by the conjugate. So multiply by the conjugate to get a real number in the denominator. All right, so let's look at some examples. So the directions, for example, 1 are to write the quotient in standard form. All right, and then don't forget, standard form is A plus BI. All right, so our first quotient is 18 minus 8i all over 2i. All right, so if you notice on this one, I know reducing these is not something everyone is super experienced at, but if there's addition or subtraction on your fraction, if you're going to reduce, you have to look at every single term and see if they can all reduce by the same value. And this one, they can all reduce by 2, so let's do that first. All right. Then we're going to multiply by the conjugate of I. So the conjugate of I is going to be negative I. All right, so in the numerator, I'm going to distribute negative I. All right, and then I times negative I is going to be negative I squared. All right. Then I'm going to kind of rearrange the order because I want the real part first. And the real part of this one is going to come from this 4i squared. So 4i squared is negative 4. And then we have the minus 9i. And then your denominator is just going to be 1. Because negative I squared is like negative 1 or positive 1. In a denominator of 1, obviously we don't need to write. So that is our quotient in standard form. Real part first, imaginary part second. Okay, let's look at B. We have 2 over 4 minus 5i. So that's the original problem. So what we're going to do is multiply by the conjugate of the denominator, which is going to be 4 plus 5i. I didn't say this in the first example, but I should have. So to keep everything legal mathematically, what you multiply by on the denominator, you also multiply by on the numerator. So on our numerator, we're going to distribute the 2 And then our denominator, because they're conjugates, we can do the shortcut multiplication, where we'll multiply 4 times 4, and then negative 5i times 5i. All right. So in our numerator, there's really nothing we can do right now. So we're going to leave that as 8 plus 10i. Our denominator, we have some things we can do. So minus 25i squared is really plus 25. And then 16 plus 25 is 41. That technically is not standard form. Standard form, you have an a and then plus a bi. So the a in this case is going to be 8 over 41. And the bi is going to be 10 over 41i. So that is technically what standard form is. You put both parts over the denominator. All right, let's look at one more. So for C, we have 4 plus 2i over 1 minus 4i. Now this is one where lots of people want to reduce, but you cannot reduce. So to be able to reduce, the 4, 2, 1, and 4 should all be able to reduce by the same thing like we had on example A, but they can't. So we can't reduce any of them. So this is the problem we're working with. So what we'll do is multiply by the conjugate of the denominator. All right, so on the numerator, we have to do all the distributing. So distributing the 4 and distributing the 2i. In the denominator, we can do shortcut distributing, so just the 1 times the 1, negative 4i times 4i. Right, and then we're just going to simplify this down. Okay, and then your last step, you're going to put both of those numbers over your denominator. And that is the answer in standard form. Okay, and now we're going to do one quadratic formula problem. Now you guys hopefully remember it. It is something that you want to remember. So we're going to use the quadratic formula to solve. And our equation is 8x squared minus 4x plus 1 equals 0. Okay, so hopefully you all remember the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so we'll just plug everything in, our ABC. All right. So inside that square root, if we did 4 times 8 times 1, that's 32. So we have 16 minus 32 is negative 16. Okay, and then the square root of negative 16 is 4i. right, and then just like before, we're going to put both of those over the denominator. And then we can reduce. We could have reduced at this step. If you wanted to, is up to you. A lot of people reduce too early, so I try to wait until the very, very end to reduce. And sometimes, like, one of the fractions will reduce and one of them won't. So I recommend you wait to the very end to reduce. All right, so your assignment is page 152 through 153, 28, 38, 52 through 60 even, 66, 72 through 80,